All right, guys, so we're going to talk about etiology here. And we're going to start by talking about genetic etiology. And the first thing to talk about is how much more heritable bipolar disorders are than the depressive disorders. And you've got the numbers in front of you, so I won't talk specifically about those. But bipolar disorder is much more genetic. And in that way, right, another way of saying that, it's much more biological. And that's going to have consequences, or is going to inform, I should say, our treatment in different ways. So we'll come back to that. There are certainly genetic markers. We're not at a place where we have reliable genetic markers. Different research studies show different allele variations. We don't have a lot of consistency in the research, and so we're still working on that. And of course, as with anything to do with disorders, we're talking about multiple gene involvement, not just one gene for any of these disorders. And remember what we talked about back in chapter 2? Genes, right? We're talking about genetic heritability. Genes affect neurotransmitter or brain function issues, and that then leads to the behaviors and experiences that we tally up to be a mood disorder. And so it's important to remember genes aren't making the disorder. Genes are affecting other biological things that then create the disorder. And one of those things that genes effect is neurotransmitters, either levels of neurotransmitters an individual has or sensitivity of receptors to neurotransmitters. And so three we're going to be most interested in with mood disorders is serotonin, dopamine, and norepinephrine. And serotonin shouldn't be any surprise given our earlier conversations about serotonin. Serotonin in the brain is mostly involved in regulation of mood, regulation of sleep, regulation of appetite, and hopefully you're making direct connections as I'm saying that to the kinds of symptoms that we see in any of the mood disorders, or likelihood of those symptoms anyway. What we are most interested in, though, is not the levels of these symptoms, though that might be a factor for some people, but it's really about the sensitivity of the receptors. And that people who have mood disorders, both depressed people and people with one of the bipolar disorders, seem to have a higher likelihood of decreased sensitivity. And remember my ticklishness analogy. Decreased sensitivity is like somebody who is not very ticklish. We take a lot of tickling to get them to have a tickle response. If you have more sensitivity, it doesn't take as much tickling, right? That's the analogy. And so if we have decreased sensitivity, it means it takes more serotonin to make the neurons fire. So even if the person has an average level of serotonin, they're going to be performing as if they have a deficit because they need more than average in order to make those neurons fire, which is why those serotonin reuptake inhibitors work so well, because they keep more serotonin in the synapse. So you're producing the same amount, you're just using more of it every time you release it. Right, because they're stopping reuptake from happening, which means that not very sensitive receptor site gets to get more of the serotonin. So hopefully that makes sense. That's a good thing to ask about when we need if it doesn't. And that's true again for both sets of disorders. Dopamine, hopefully you remember, is really part of our reward system. The limbic system, striatum are all part of our reward system. And again, important in all of the mood disorders, but in very different ways, depending on whether we're talking about the depressive disorders or we're talking about disorders that include mania. So in people who have risk of mania, people with those bipolar disorders, that they have an increased sensitivity to reward. And so essentially, there's the higher, with any given activity, there's a higher likelihood that the person's going to find that rewarding. If we find activity more rewarding, we engage in more activity. And so you can see that increased level, that increased activity level that we see in people who have manic symptoms. The opposite is true for people who are depressed. They have underactive reward systems. And so often, kind of anecdotally, people who have suffered with depression often are people who never finish tasks. Like start a project and they get 90% of the way through and they don't finish it. And really you can think about that most of us push through and finish a project because it's going to feel so good to be done. It's going to feel so satisfying to have accomplished this That's all based on having adequate dopamine. If you don't have adequate dopamine, then the last 10% of the work may not feel worth it, right? That you in the past have not had the same kind of reward that other people may experience. You're not expecting necessarily to feel so good when you're done, and so maybe you just leave it and you don't do it, right? And so dopamine becomes really important in understanding those kinds of symptoms in both of these sets of disorders. All right. And then the last one is norepinephrine. Remember, norepinephrine is an excitatory neurotransmitter, so it's not going to be a surprise that more norepinephrine is going to be involved with mania and states of mania, and that decreased use of norepinephrine is likely to be present in depressed populations. We do have medications. We'll talk about medications in a few minutes, but we do have medications in addition to the SSRIs. We also have SNRIs, where it interferes with the reuptake of norepinephrine. And we also have antidepressants that work on dopamine for the reasons that we talked about in the last slide. And so if we change gears here just a little bit and think about brain function, the amygdala, as I said in an earlier video, is going to be an important player here. And remember, the amygdala is our alarm system. And so if we just think about depression for a moment, we do see increased activity in the amygdala. And so we're more emotionally responsive, essentially, that when things happen in the environment, we have a bigger emotional response to it, and especially a stress response, a negative response. And so, so that's kind of the baseline. But then we also have decreases in activity in areas, one called the subgenual anterior cingulate, and the other is the dorsolateral prefrontal cortex. And for your purposes, you can just think of that as the cortex. The cingulate runs between our limbic system and our frontal lobe. And so the communication with the limbic system and the frontal lobe, and then the frontal lobe itself, both have decreased activity. And they're both involved in emotional regulation, right? So the limbic system, especially the amygdala, reacts with raw emotion. If things are going well in the anterior cingulate or in the prefrontal cortex, we can dampen that reaction. But if there's not enough activity, we can't dampen that reaction. And now we're experiencing in an almost raw form that emotion coming from the amygdala. So we don't have that emotional regulation. And so I often talk about this, and I think it's a useful way of thinking about it, as a sense of emotional brittleness, and that the goal in therapy for many depressed people is to help them feel more emotionally resilient. And so, like, difficult things happen in many people's lives, probably in all of our lives. But if we are more depressive, we're more likely to not have more likely to react strongly to those things, and to feel brittle in the sense that we can't moderate our emotional reaction to them. And so I think that's a big piece of how we should understand depression from a brain point of view. From a mania point of view, we also see elevated amygdala activity, but remember, the amygdala is our alarm response. It's fight or flight, right? In people who are depressed, there is more likely to be a flight response, which is that retreat response, right? So people who are depressed retreat from people, they do less activity, right? They retreat. But there's also that fight response, and in bipolar, and another way, in addition to like fight or flight, is the kind of retreat or go towards, is another way of thinking about fight or flight. In bipolar disorder, that elevated amygdala activity means that we go towards, like that there's an emotional response, and I want to go towards the thing causing the emotional response. We have more activity in the anterior cingulate and diminished activity in the hippocampus and in the frontal lobe. And so the result of these things is that the less activity in the frontal lobe means that we don't have as much impulse control. So we have an emotional response with a drive to go towards. And then where an active frontal lobe might say, no, like that's not going to be good for you. There's a less active frontal lobe that doesn't say that, right? It's more silent. And at the same time, the hippocampus, which is about our explicit memory, that might say, oh, the last time you did this, that didn't work out so well, it has diminished activity as well. And so we're just more likely to, right? So we have increased amygdala, that anterior cingulate is transfers emotion to the frontal lobe, it's working well, and so, right, and yet the impulse control is not working well, and so then we decide on activities based on that emotion. And of course, as we said before, we also have dopamine that's more active, and that's happening in the striatum, which is also in the limbic system. That's overly active, and so we're also seeking reward more. And those things are going to coalesce, come together to really make it likely that in this state, that the brain that's functioning this way is going to be really interested in lots of things that provoke emotion, and not pay a lot of attention to risk and only pay attention to reward. So that really is a good brain description of what's happening in a manic state. Other biological issues to kind of pay attention to here in terms of etiology, that in people who are depressed, neurons are simply less likely to fire in some ways kind of throughout the cerebral cortex, and that they're more likely to fire in bipolar disorder, so there's less activity and more activity in this kind of global way, and that has to do with those G proteins that we thought about when we were talking about epigenetics. And those rat pups, and so we wind up with just differences in responsiveness in our postsynaptic cells. We also, people with mood disorders, again, this has to do with this brittleness I talked about, just have a heightened, remember that HPA response, the hypothalamus, pituitary, adrenal response. That is, we have a heightened response in people with mood disorders, and then poor regulation of that response. And so that's about ongoing stress, not just immediate events, but in an ongoing way, how good are we at recovering from stressful events? All right, so we're going to pause there, and then we have one last video to think about other factors and then treatment.